Have you ever wondered how big companies manage their vast amounts of data? Welcome to the intricate world of advanced database systems, the unsung heroes of the data world. These systems are the backbone of data management, processing, and analysis, pivotal in the operations of every major organization today. Imagine a grand library with an infinite number of books, and you're the librarian. Advanced database systems are the librarian's tools. They help categorize, store, retrieve, and make sense of these countless books. From handling big data and data warehousing to explorations into data mining and knowledge discovery, these systems encompass a broad spectrum of techniques and technologies. They also delve into specialized areas like spatial and temporal databases, graph databases, in-memory databases, and even blockchain technologies. It's a fascinating landscape, rich with potential for innovation and discovery. So buckle up and prepare for an enlightening journey into the heart of data management. Stay tuned as we delve deeper into these advanced database topics. First off, let's dive into the world of big data management. This fascinating field revolves around handling and analyzing massive volumes of data. We're talking about quantities so vast that they exceed the capabilities of traditional database systems. Big data can be both structured and unstructured, encompassing an array of information from social media posts to scientific research data. To manage this data avalanche, we employ distributed storage and processing frameworks. You've probably heard of some of them, such as Hadoop and Spark. These tools allow us to store and process data across multiple servers, maximizing efficiency. And let's not forget NoSQL databases, which offer flexibility when dealing with a variety of data types. In the world of big data, we also delve into stream processing and techniques for data integration and cleansing. These processes help us transform raw, messy data into something meaningful and ready for analysis. Big data management is a vital aspect of advanced database systems. Now let's move on to data warehousing and OLAP. Data warehousing is all about creating large-scale repositories. These are designed to store and analyze historical data from a variety of different sources. Picture a massive library, but instead of books, it's filled with data. This data is collected over time, providing a historical context that can be incredibly valuable in understanding trends, patterns, and changes. Now, enter online analytical processing, or OLAP. OLAP techniques allow for a multidimensional analysis of this data. Imagine being able to pick up a book from our library and explore it from all angles, peering into every nook and cranny to extract as much information as possible. This deep dive into data is what OLAP is all about. It's a tool that enables decision support and powers business intelligence applications. In essence, both data warehousing and OLAP are like two sides of the same coin. They work hand in hand, providing a comprehensive solution for storing and analyzing data. Data warehousing and OLAP are crucial for any data-driven business. Next on the list are graph databases and network analysis. Diving right in, graph databases are a unique breed of data management systems. They're designed to excel in storing and querying data structured as graphs. Think of social networks, biological networks, or transportation networks. In these scenarios, data isn't just about individual elements, but also about how these elements connect and relate to each other. For instance, in a social network, it's not just about who the users are, but who they're friends with, what groups they're part of, and how they interact. This is where graph databases shine. They store these relationships as first-class entities, making queries about connections swift and efficient. Tying into this is network analysis, the practice of scrutinizing and modeling these complex networks. By analyzing relationships and interactions, we can unearth valuable insights, predict trends, and make more informed decisions. Graph databases and network analysis offer versatile solutions for complex network data. Let's now delve into in-memory databases and real-time analytics. In-memory databases, as their name suggests, store data primarily in random access memory, or RAM. This is a stark contrast to traditional databases which store data on disk. The advantage? Speed. RAM is much faster than disk storage, and this speed allows for quicker data access and processing. This is particularly useful in scenarios where rapid response times are critical, such as financial trading or emergency services. Now, let's talk about real-time analytics. This is the process of using data as soon as it becomes available. Imagine a river of data flowing in, and as each droplet hits the surface, it's immediately analyzed and used. This allows businesses to make decisions based on the very latest information, which can be crucial in fast-paced sectors like e-commerce or social media. In-memory databases and real-time analytics are at the heart of high-performance data processing. Now let's talk about a crucial aspect: database security and privacy. In our interconnected and data-driven world, database security and privacy take center stage. Advanced security measures include methods such as encryption, which transforms data into unreadable formats unless decrypted with the correct key. This ensures that even if unauthorized individuals gain access to your data, they can't make sense of it. Then we have access control mechanisms, which are like bouncers at a club. They regulate who gets in, when, and what they can do once inside. By assigning roles and permissions, we ensure that only authorized users can access specific data. Data masking is another essential tool. It hides sensitive data, replacing it with fictitious yet functional data. It's like giving someone a decoy while keeping the real treasure safe. Finally, compliance with data protection regulations like GDPR and HIPAA is not just good practice, it's the law. These regulations ensure that data is handled responsibly, protecting individuals' privacy rights. Database security and privacy are indispensable in today's data-centric world. Next up is cloud databases and database as a service, or DBAS. So what exactly are cloud databases? Well, these are databases that are built, deployed, and delivered through a platform that resides in the cloud. This means they leverage the flexibility and efficiency of cloud computing infrastructure, providing scalable, on-demand database services. Now let's talk about DBAS. Database as a service, as the name implies, is a database provided as a service to customers over the internet. It's an approach that offers a number of compelling features. First, there's elasticity, which allows the database to expand and contract based on demand. Then, there's high availability, ensuring that your database is always up and running. And lastly, automated management tasks take the burden off your shoulders, allowing you to focus on what truly matters. In essence, cloud databases and DBAS are revolutionizing the way we manage databases. Finally, let's delve into database performance tuning and optimization. This is a crucial area in advanced database systems. Performance tuning is the art of enhancing database operations to ensure they're as streamlined and efficient as possible. It's about making sure your data is accessible at the right time, in the right place, and in the most efficient manner. One key strategy is query optimization. This involves tweaking the queries to ensure they return results quickly and efficiently. Next is indexing, a method that organizes data similar to a book's index, allowing the database to find and retrieve data much faster. Another strategy is caching mechanisms, which store data temporarily in places where it can be accessed swiftly. Finally, workload management helps distribute the database tasks evenly, preventing system overloads and bottlenecks. In a nutshell, these strategies are the nuts and bolts of database performance tuning and optimization. They ensure efficient and effective database operations. That brings us to the end of our exploration of advanced topics in database systems. Today, we've covered a broad spectrum of specialized areas that go beyond the basics of database management. We've delved into the realm of big data, dissecting how technologies like distributed storage and processing frameworks, NoSQL databases, and stream processing are instrumental in managing colossal volumes of data. We then ventured into data warehousing and OLAP, underscoring the importance of comprehensive repositories for storing and analyzing data. We highlighted the relevance of multidimensional analysis for decision support and business intelligence applications. Exploring the world of graph databases and network analysis, we discussed how these specialized databases store and query graph-structured data, reflecting the interconnected world we live in. We also touched upon in-memory databases and real-time analytics, emphasizing the need for speed in our fast-paced, data-driven world. We discussed how storing data in RAM allows for faster access and processing, enabling real-time analytics and high-performance transaction processing. We stressed the importance of database security and privacy, discussing advanced topics like encryption, access control mechanisms, data masking, and compliance with data protection regulations. Our journey also took us to the cloud, exploring cloud databases and database as a service, DBAS. We highlighted the benefits of leveraging cloud computing infrastructure for scalable, on-demand database services. Finally, we looked at database performance tuning and optimization, focusing on strategies for enhancing database performance through query optimization, indexing strategies, caching mechanisms, and workload management. Understanding these advanced topics is crucial for anyone working with large-scale databases. They not only equip you to handle vast volumes of data, but also enable you to do so efficiently and effectively. They provide the skills necessary to navigate the complexities of modern data management, offering tools and techniques to turn data into actionable insights. Remember, mastering these advanced database topics is key to managing large volumes of data effectively and efficiently.